Okay, so here's a second example, example 2 of a claim, and we would look at it to try to figure out what's going on, and so you know, say it's some manufacturing process. And what they want is, you know, so they want, well, less than, so they want less than, so I'll do a less than sign, 2.5% defects in whatever they're making. And, you know, in some things that would sound to me really high, and in others it probably doesn't sound too bad. I suppose it depends a lot on what they're making and how hard it is to make and that kind of thing. But so suppose they've decided their manufacturing process is pretty good if they can have fewer than 2.5% defects. And now, so they're not necessarily claiming at this point to have that. They just want that to be the case. Okay, so so we're going to treat that as a claim. You know, treat and in this case what we're going to say is exactly 2.5% or 0.025 defects as the claim. Now this is an important part about our claims, or what we call our null hypothesis. So our claim is our H0 or null hypothesis. And it needs to be an equality. Okay, it needs to be a single case. So we want this, but in our language of statistics, what we're going to have to say as far as our process, our statistical process and so forth, is we're going to have to pick a number. Okay, we can't say, well, okay, our claim is it's less than or equal to 2.5%. No, that's not going to work. We don't know how to do that. So we're going to say, okay, it's 2.5%. And if we go sample it and it's less than 2.5%, then we're probably pretty happy. But if it's more than 2.5%, ooh, you know, maybe not so good. And so, okay, so that's what we'll do is we're going to treat this as equal to 2.5%. So that's our claim, is 0.025 defects per, you know, one item. So on, you know, our proportion of defects is 0.025. Well, so, you know, what might we do? Well, in this case, we could go out and sample 40 items. Okay, why 40? Why not? We could sample 100 items, we could sample whatever. Now, part of the reason actually I choose 40 is just because if I take 0.025 times 40, you know, I get 1. So that's, you know, this would say on the whole, right, if I really think there are no more than 2.5% defects, I would hope that in a usual batch of 40, I would tend to see like 1 defective item or 0 defective items or something like that. Okay? Now, so I sample 40 items, you know, and I just chose it because it made that nice 1 with the 2.5%. But I sample 40 items and find, let's see, how many do I find? I find 3 defective items. Okay, so the question is, you know, should I reject the claim of 2.5% defective? And this is the thing, you know, I mean, on the surface it looks like, well, sure I should, right? Because I find 3 defective items. I wanted just 1 or fewer, right? 1 or 0, but I found 3. But, you know, that's the thing, is I sampled from a big population, so I could have just gotten an unlucky sample, or maybe I didn't, you know, and so what we want to do is check, well, okay, if it really is, if this is true, so we're going to assume our proportion P is equal to 0.025, and we're going to make a coin like this, okay? Find a coin with 0.025 heads and 0.975 tails. That'd be a funky looking coin, but you know, we find that coin, and again we flip it 40 times. And count the heads. Because you see, that's what we were doing up here. We want to create our assumption. Okay, and our assumption came from our claim. Our claim was 2.5% defects. But what did we do? We sampled 40 items. And so from our assumption, we should be able to take this really funky coin that we have here and flip it 40 times, count the heads, just like we did with a fair coin, and see what happens. Well, do this 1,000 times this time instead of just 100. Let's do it 1,000 times. Okay, and here's maybe what we find. Okay, so 0 heads, that would be, you know, a nice thing. 0 heads, I guess, that would be no defects in our batch of 40. So 0 heads, and maybe we find that out of 1,000, we find that happens 363 times. 1 head, we find happens maybe like 373 times. 2 heads, we find happens 186 times. 3 heads, now that's what we actually got. We find that that happens 60 times. 4 heads, suppose with 4 heads, That happens, well, I don't know. Let's try to get this to 1,000 reasonably well here. What do we have? So here is 600, 736 to there. And then 800, 922, I think. And then 982. So we still have 18 left, and so just to make our life easier, let's say there were 18 there. It could have been, 10 here and 8 at 5 or even 6 or something like that. But there, if I counted right, there's our 1,000 times. So again, our data, right? We oops, didn't go up far enough. We found 3 defective items in our sample of 40. And so that's what we found. Now, assuming assuming 0.025 for our proportion of defects, what we found by sampling 40 pieces out of a population of 0.025 and doing that 1,000 times, what we found was that there were 78 out of 1,000, which is equal to 0.078. Now, in this case, though, okay, that's bigger than 5%. And so, since it's bigger than 5%, we're going to fail to reject our claim H0. Okay, this is our claim of P equals 0.025. So if somebody's trying to, say, hey, I got 3 defectives out of there. We really should only get 1. Therefore, you have more than 2.5% defective in your overall manufacturing process. Well, we don't have data to support their claim, okay? Because we cannot reject the idea that there are 2.5% defective in here. Now, this is not truly how you tend to do quality control in something like this, but it's, again, as I keep saying, don't wreck a good story with facts. It's a good way to just kind of try to visualize and get some intuition for what it is we're doing. And again, all we're doing is, hey, we're making this claim. Now, is anybody really making this claim? Well, no. I mean, actually, it's just, this is our goal, right? This is our goal. We're hoping this is the case, that we can treat our batches as though they have, this no more or about 2.5% defects. That's our claim. We go out, we sample our 40 items. Unfortunately, instead of just 1 defect where we'd or 0, where we'd go, oh yes, we know what we're doing, this is great, we found 3 defects. Okay, is all lost? Well, not necessarily. It's when we check, well, how likely could this have been true, our 0.025? How likely could that have been true? And we still got 3 defective items. Well, we go down, we check that out. We say, okay, well, let's assume that. Then what happens if we assume that? And here's our distribution. we would expect somewhere around 36% of the time to have no defects show up. Around 37% of the time, so 36% up here, 37% of the time have one defect show up. About 19% of the time have two defects show up. About 6% of the time, because it's 60 out of 1,000, so about 6% of the time have three defects show up, and getting close to 2% of the time, because 1.8 out of 1,000, or 18 out of 1,000, which is 1.8 out of 100, getting close to about 2% of the time, we would have as many as 4 defects show up. And that's if this is true. And so, well, it could have just happened by chance that we just got an unlucky batch, and that batch of 40 had the 78, had the 3 bad items, but that could happen 7.8% of the time. And so, right now, we're stuck. Now, what would happen in real life? Well, we'd probably do a bunch more testing, okay, because we failed to reject H0. But in this case, we probably aren't real sure about it. You know, it's not like I'm going to run out and go, oh, yeah, we're doing 2.5%. Actually, you know, I would say, ooh, I don't know, are we? You know, and I would want more data. Well, actually, that tends to be what happens when we fail to reject a null hypothesis in our work. Often the answer is, oh, well, maybe we better go out and collect more data. Okay, but there you go. There is a second example of just kind of this big idea and how our simulation works to do this, and so we have this solution in this case where, well, it could happen just barely often enough, a little more than 5%, and so we're stuck with our claim, even though you know, you might say, oh, well, that's good, but it doesn't give me warm fuzzies in this case. Okay, but we do fail to reject the null hypothesis, and so, yeah, for right now, we'll keep assuming that we're at 2.5% defects. Okay, but we probably wouldn't be very easy about that. Okay, so that is our second example.